In continuation from the previous video, now we are going to solve the limiting problems from exercise 13.2. This is the first one, 4 part 2, limit x tends to 0, 3 cos x by x minus pi, taking x minus pi equals to h, where x tends to 0, so h tends to pi. Now limit h tends to pi, the changed limit of 3 cos h plus pi divided by h. We can write it as limit h tends to pi minus 3 cos h by h. So we can write it as minus 3 into 1 is equal to minus 3. Now question number 7 part 2, limit x tends to 0 of sin ax by sin bx raised n, where n is a natural number. So x tends to 0 of sin ax by x, we can write it as sin ax by x divided by limit of x tends to sin bx by x whole raised n. So we can write it as a raised n for the numerator and b raised n for the denominator. So a by b raised n. 14 part 2, sin 5x minus sin 3x whole divided by sin x. By using the formula sin c minus sin d, we can write it as limit x tends to 0 to sin x into cos of 4x divided by sin x. By simplifying these two, limit x tends to 0 to cos 4x. Further we can write it as 2 into 1 equals to 2. Now 15 part 2, given limit x tends to 0, root 2 minus under root 1 plus cos x whole divided by sin square x. Limit x tends to 0, root 2 minus under root 2 cos square x by 2, for by using the the formula of 1 plus cos x by sin square x, submultiple formula, limiting x tends to 0, root 2 minus root 2 into cos x by 2. Further we can write it as limit x tends to 0, root 2 taken common, 1 minus cos x by 2 by sin square x, limit x tends to 0, root 2 into sin square x by 2 whole divided by 2 into, for this one, 2 sin x by 2 into cos x by 2 whole square, as it is written as 2 sin x into sin x. Further we can write it as into 1 plus cos x by 2. By using the limiting value here, limit x tends to 0, root 2 by simplifying these two, we can write it as root 2 divided by 4 into cos square x by 2 into 1 plus cos x by 2. Further we can write it root 2 by 4. Hope you will understand the solutions. Thank you everyone.